Okay, I hope you had a restoring coffee break. And we start back from Patrick Gorringe, sorry, and from SMHI. Patrick will introduce us to the new UNDCAD endorsed project called SCOOPp, Solution for Cost-Effective Ocean Observation Platform Project. Please, Patrick, the floor is yours.
Thanks, Giovanni. Let's get going. Have a seat, Giovanni. Enjoy the next, I say 10 minutes, maybe a little bit overdoing that. No, okay, I won't do that. I'm Patrick Orange, like you said, I'm based at SMHI in Sweden, together with my colleague, Emily Brevier. Come on, Emily, wave. Yeah, we noticed a need and an opportunity within the ocean community some years ago. And to explore and meet that need, we set up SCOOPp, the Solutions for Cost-Effective Ocean Observation Platform. It's pretty much that was the goal. Because if you look at from the ocean decade to GOOS down to very local level, there's a need for more ocean data. We all know that. We need more data, but that also comes with a cost. And the more traditional ways that we measure in the oceans can be a little bit pricey sometimes. So instead, we need to look at making these observations more affordable and accessible to more people. I'm thinking citizens and others. That's what we think about. So what we did in 2023 was that we wanted to know who are in the community, who are the sensor developers around? What community is already like using already existing platforms such as Cooper down there, Cooper, using already existing platforms, in this case, fishing boats to put sensors on. So we don't have to pay for the platform itself, we're just reusing an existing platform. Who are they? So we set up a number of workshops throughout 2023. The first one we had was organized under the Atlantus program, where we invited people online, presenting themselves, showing what they do, what kind of sensors they're running. And then that kept going. We had one that was organized by MBON, GOOS. The one under GOOS was also a focus on the data management component. So if you reach out to communities to teach them and guide them through how to set up the data, so we actually get interoperable data streams and make the data available. At the grand finale of the ocean race in Genoa, we had a super session for a full day, packed room with sensor developers, data managers, citizen scientists, all just sharing a lot of information about this with each other. So it's been this momentum building, and to meet all this stuff, we had to do something to create something to meet the needs. But it's also been noticed in scientific publications. I use one also from the Fishing Vessel Ocean Observing Network here. We published that in 2023, but also in more like popular magazines and publications. The one in the middle there, Shore Patrol, it's a colleague of mine, Fernando, who is deploying this little thing. It's a temperature logger all over the full Atlantic. There are thousands of these that are used in a project for biodiversity studies. That's a very nice one if you want to have a look at that one. And then to the right, Anahita and her colleague Karen, who some years ago, they looked at how we observe in the oceans, and they thought we can do that in a much better way. And they came up with a mini vessel that they put pretty low-cost sensors on top of that vessel, and off it goes. And it's been pretty amazing the impact that's had. So they had a nice one in the Guardian. They also been in the BBC. They were even nominated, or they even won the Innovation of the Year in the UK for their activities. So it's a momentum going on and a lot happening in this space. I need this. Yeah, I need this one for that. So Emily and I, we've been we've been noticing that there's stuff going on. And we booked a room for half a day just to do a brainstorm around it, and that we need something to meet these needs. We wanted to come out with that, but we came out with this because there were so many components that we started to list on our little whiteboard. It took some hours, didn't it? So starting with IOC and Goose, the decade, CoastPredict, Global Coast, they're all components there. This was in December 2023. The data component with EMONet and Copernicus, but then also a number of decade actions, such as Sailing for Science, Erasmus Maris, CoLab, and others, because what we wanted to do was to bring these different decade actions under one umbrella. They often work in silos. They don't really talk to each other. So we thought if we bring them together and maximize the use of what they do, that's going to help, to boost what we do. And we came up with that, something with no name, but it is now called SCOOPp. That is ticking off basically, or addressing all these different boxes. So we thought that was pretty cool to show, because it was a super brainstorm session, but it's still very relevant. I better hurry up, right, Giovanni? So what it is about, it's a global collaborative initiative connecting low-cost sensor developers, data managers, data collectors, and users to really enhance the number of data that's available. And we can support that by managing, but also informing them about how to set up data streams in an interoperable manner. There's a website, you can see it there. That website is really the tip of the iceberg. And what's really is going on is below the surface. But currently, because this thing is evolving all the time, what you find there is a catalog of low-cost sensors that we have identified, an ever-increasing list, because we get new ones almost on a weekly basis, I would say. We are building this website together with colleagues in the US, based in Monterey Bay, because they are doing something similar on the decade action called Synchro. So we thought, let's build this together from day one. Instead of going in parallel, let's do it together. So that's what we're doing on this website. It provides documentation and the expertise for users to help them to optimize the data collection, and also to ensure that data collected are fair, following the fair principles. If you go there, landing page, go to the catalog, click on a sensor, you find all kinds of metadata about that particular sensor. So it's a shopping place for people who want this kind of technologies that want to explore it. It's currently powered by Lancelot, which is an EU project, EMONet, the program EMONet, Jericho, Synchro, as I mentioned earlier, and also CoastPredict. And it was endorsed as decade action in July 2024. And since then, it's been a pretty massive progress going on. We had another workshop together with Goose, NOAA, and MTS. We had that during the Barcelona conference. A lot of the good people in that room, a lot of motivation going on. And we also see how this very well fits into the pilot sites of Global Coast. So it's been a super active year. We have invitations all over the place to present on this as well. So when that momentum is growing, they also ask us if we can come along and make some presentations. So the up to summer is pretty packed, but we're having fun and we're enjoying it. I showed you the iceberg earlier. So everything below the surface, we're trying to boost that with whatever kind of existing projects or initiatives that are running. And Giovanni, you mentioned CSMAC 1 already. We have this one. We're planning a kickoff meeting in June. That will be one component under SCOOPp and a feeding SCOOPp. And it's really mobilizing the European Marine Citizen Science Data Network with a focus on the data. Not necessarily pulling the citizen scientists together, but getting their data and making that available to, for instance, EMONet, and in turn to Copernicus and Edito. This is the plan with that one. And also to create that trust, because citizen science has a bit of a, among some scientists, So we need to prove that this is good data and we should go for it. Elevating citizen science data to a high level and providing the tools needed to guide them through setting up these data streams. That's what that project is about. Give me 30 seconds. If you want to have a look at some of these cool things out here. This is the one we put on the fishing nets. When we go out and we put on the fishing nets, it goes along with when they go fishing, and we get temperature profiles from pretty much all over the place, Cooper. Here's a little temperature logger. It's about 50 euros for one of these. Battery life of 15 years. Cool stuff too. Or how about this little thing? I mean, how cool is that? You put it on your fishing rod, right? That's what you do. And you get a profile of the temperature, salinity, and light with this thing. Everything in real time, straight into your mobile phone, and we get the data, bang, we get hold of that data. Just 3 examples to show you, right? And now I have to cut. I have to. Did I really do that much overtime? No.
No.
Good.
I can stay here for a moment. Is there any question? I guess there are. I know you want to touch this cool stuff, but apart that, any question from the audience? Yeah, Nadia.
So, thank you so much for SCOOPp and all the work of coordinating and interfacing. So now it's a bit of a question about companies working and interfacing with them in a way that, leaves a bit competitive aspects. So what is the way out? So now you have some companies that do that, and then you have others. Can we use also the Global Coast to do some intercomparison with the companies that can show their products and
of course
evaluate?
That's really what we should do as well. So of course we can do that.
Okay.
Look at you, Emily. You're just nodding, right? I mean, this is a given.
Thank you. Yes, because actually we have via the Lancelot project, we have some case study where there will be comparison between the cost-effective sensors and the traditional, so benchmarking and all that. Yeah. So we'll have results.
We built a pretty amazing network here. So from my network 2 years ago, it's like got 5 times bigger because we're connecting directly to sensor developers and also other initiatives around. So it's got pretty massive, and it's global. It's clearly a global thing. We're not stuck to Europe. We're going globally. We're building together with US, and we have interest from other countries around the world that wants to join. So it's, yeah.
I like the idea to start on data management as soon as possible. So I totally support it, because otherwise, but also getting the company community, the companies working for some intercomparison.
We realized that so far, no competition. We can get 20 companies into a room, and they're all keen on to share experiences. We felt no competition so far, which is...
Yeah, I mean, just a comment. I think we need to use this Horizon project with a bit of funding to really keep the worldwide community together. So maybe when you organize the workshop, do it at international level, also the kickoff meeting, so that people feel...
For the pilot.
Yeah, for the pilot, of course, for our community. And maybe invite also the industry, because the next assembly we can distribute the sensors, and then people get back home with knowledge, and we can organize workshop, training workshop, and so on. So, but keep the pilot in mind. They are the test bed for the citizen science.
That's what we do. We have all that in our brains.
Thank you, Patrick. Thank you, Emily.
Leave these things up here if someone wants to have a look around.
Don't take it with you.
Just circulate. Yeah, just put it. Okay, now next speaker is Joanna Staneva from Arion. She will present the Forecasting Ocean to Coast Connecting User FOCCUS project. It's an Horizon 2020 project.
Yeah, So actually, I'm very happy now that after the very fascinating the presentation about engaging users and observations, we will go through the forecasting ocean to coast and connecting users. And this is the FOCCUS project. And I will start at explaining the objectives of the projects, the key element, and why this is also very important. Of course, as a coastal Copernicus, so this is the nickname of the FOCCUS project, we started as European initiative, and this is Horizon Europe funded project. But we want to go beyond the Europe because we are only stronger if we work as a worldwide community together. And we want to work towards the innovative approach for marine knowledge, to exchange the software, to exchange the developments, to have the data, but also to train the early career researchers. And this is why I will show you briefly our objectives and motivations and the 3 pillars that we are working, and we'll provide you the information of how you can interconnect each other. And why this is very important is because we want to provide smart knowledge for the decision makers and the users. We want also to develop and enhance the future coastal operational services. But what is crucial is that they are harmonized and synchronized. And we want to contribute to the coastal digital twin of ocean community by bringing our applications into the coastal digital twin of ocean. As I already mentioned, and as Giovanni also presented, this is a Horizon Europe funded project that started with, which is a FOCCUS for a Coastal Copernicus program. And within the CoastPredict FOCCUS project, we are core team of 6 partners within Europe, but we want to be as much as possible inclusive and involve coastal systems worldwide. And we have already started with connecting and attracting more coastal systems, but everyone here is welcome to join and to contribute in addition to our core pilots within Europe and in addition to our core pilots in other continents like Asia, Africa, South America, and North America, but also Arctic. And our objectives within forecasting land to sea and connecting users are structured in the 3 pillars. It includes the novel high-resolution observations that has been mentioned in Nadia as a crucial element for the coastal forecasting community, linking with hydrology model, as well as new approaches for connecting land to sea through the box model, artificial intelligence. Then the new innovative methodology for the coastal modeling, because we have to have in mind that the coastal models are broad and a new methodology has to be developed, which not always what is available for the global and regional can be transferred for the coastal area. And then, of course, towards the applications and integrated into Copernicus program, integrated into the UN Ocean Decade, and integrated into the digital twin. And the aim is to have the worldwide operational fit for use coastal international information services. And the objectives is to consolidate the efforts worldwide toward the novel approaches for better constraint toward the key coastal applications, and then the advance these for the upscaling support within the global coast community, for upscaling in the area which are not well representative or underrepresentative, but also to allow the users to engage within the design of the different coastal applications for the very beginning, as well as to train the early career researchers, which are the future coastal forecasters. And very briefly, toward the different pillars, we start with the innovative coastal observations, and then what is needed within the coastal area. Those are the enhanced coastal observations, like mentioning the high-resolution sea surface temperature. What is also important are the remote sensing observational data fusion, which can be done through the artificial intelligence and novel approaches. We need also AI applied information information for the coastal erosion, like beach imaginary, coastal lines, the bathymetry, but very important, we are doing to the coast, and we have to connect with the land, and this is where we also need a consolidated river data flow. Then the second element, this is the improved land to ocean interfaces. And this, we are going within the European project for the pan-European, but the aim within the CoastPredict program is from pan-European to go to the global hydrological models and how they can be applied for the coastal areas. We want to revise the river runoff, including the novel element, because the river runoff is not only the water discharge, it is the nutrient, the sediments, to use the novel techniques, including artificial intelligence and box models to connect the hydrology with our coastal models. And of course, we explore the different unstructured grid models Europe-wide and worldwide. Then we proceed further. We have already observations, we have hydrology. Then the third part is the integrated coastal models. We are pretty well aware that there is a broad number of many different coastal models. Most of them are structure or downscale structure models, but we want also to develop new approaches like the novel ensemble approaches for data simulation for the coastal areas, the artificial approaches, for example, for the downscaling. And here this is an example of the coastal downscaling, as well as for the specific new processes for coupling with sediment, with biogeochemical, and coupling between the different components. And then we are going forward the different applications, and these applications have to serve environmental and social needs. And these applications are also in the three topics. The one is about the hazards. The second one is about the blue economy and sustainable energy. And the third one is on the coastal resilience and nature-based solutions. And here, these are a few examples of that. More about this will be during the CoastPredict workshop. The one about the coastal hazard is of how marine heat waves influence the coastal dynamics and biogeochemistry. This is the talk of Heshan for the German biogeochemistry. And the second example, this is for the nature-based solutions within the different areas worldwide, not only Europe, but we show applications also in the Africa coast. So we are doing also for the Asia coast. And this is a talk by the ECOP scientists from Ghana for the Africa talk, as well as for the Predict on Time presentation tomorrow. And finally, what is crucial for us as a coastal community and coastal forecaster, this is the uptake and communications. And what we develop has to be uptaken from all the national and local coastal forecasting services. Nadia mentioned the use of the high-resolution data from the ministry, but this is also the use of the forecast, the use of our applications. And this is where we can also be stronger as the community. More details about that you can see in the FOCCUS website. You can register for the news and also watch the video on that. And what I mentioned is the integration of the CoastPredict and FOCCUS particularly within the coastal digital twin of oceans. And we are working towards enhancing the use cases for the D2 program and connecting use cases from the CoastPredict and the coastal communities also in the D2 program. And here two examples. The one is for the nature-based solutions, which is really coastal relevant and important, and there are many developments worldwide in which we can network and work together. And the second one is on the blue economy. And specifically, a hot topic is how we can use the different resources, for example, offshore wind energy together with aquaculture within the coastal areas. And Networking is not only through the Digital Twin program, but also through many others programs, like at the European level, there are a lot within the ocean missions and the Copernicus program, but also at the international level, the CoastPredict and Predict on Time is very well suited to connect with many other programs. Thank you.
Thank you so much, Joanna. Any questions for Joanna? Yeah, I mean, similar to what I was saying to Patrick earlier, maybe we should use a bit more focus to engage, or at least to share the outcome of focus with the pilot sites also at the international level. So maybe we can push on that, and maybe when we do training and workshops in the coming year, then we can invite people from worldwide community, let's say.
What we can do is when we have the European General Assembly of FOCCUS, we can also invite the international community, as well as in the UN Ocean Decade meetings and conferences, and then connect it. Because the aim is really to collaborate towards having open source products, open source codes, and open source model for improving the cost of forecasts.
Yeah. Okay, thank you, Joanna, again. So next presentation is online, is Nicole Jones presenting Advancing Prediction of Marine Heat Wave. Nicole is from University of Western Australia. Nicole, do you hear us?
I do, and I've just turned my video on as well. So now I'm going to share my screen. And sorry, I'm not a strong Zoom user anymore.
You don't see the full screen. Yes, that's a good one.
Is that good like that? Is that the full screen? No?
Yes, it is. Perfect.
Okay, excellent. All right. All right, I get full marks there. First of all, sorry that I can't be there in person. So I'm going to describe a project that we have going on in Western Australia at the moment, which was had a little bit of a strange direction into the UN Ocean Decade program, in that it was first endorsed but not under a program, and then we have taken a really long time to find a home. So we're quite a ways into the project, and now we're finally introducing you all to it. But thanks for accepting our project into your program. So this project was initiated in Western Australia in response to a call from our fisheries agency, who wanted enhanced tools for decision-making during extreme marine heatwave events. It involves 4 of the universities here in Western Australia, as well as government and the Australian Institute of Marine Science. And today I'm just listing 4 of us as contributors, because I'm really going to focus on one aspect of the project, which is the statistical downscaling that we're doing. So, but the project is very kind of multidisciplinary, and I'll introduce you to some of the aspects of that in a minute. Just for thoroughness, the project commenced in September 2022 and will be completed in April 2027. So in Western Australia, we've been impacted quite heavily by marine heat waves, with the most significant to date being one that occurred in the summer of 2010-2011. And this marine heat wave devastated fisheries over quite extensive regions down the West Australian coastline. with some of these habitats actually not fully recovered, or some not really even starting to recover after more than 10 years. And unfortunately, we are in summer here, and we are experiencing another severe marine heat wave, which is resulting in large numbers of fish being killed at regions of the Pilbara coast. I'll just use my little pointer here, which is up in this region. And what we are concerned about is how the Lewin Current will then strengthen and move these tropical waters down into the regions off the coast of this region of Western Australia and down to Perth, where I am. So what the project is doing is really trying to address this question of how do we prepare for a marine heat wave. And we're taking both a physics-based kind of approach to understand some of the processes better. We're taking a statistical approach where we're using machine learning techniques to downscale very large-scale forecasts. And we're also looking at past ecological data, so we can also predict ecological response. And so the project, some pictures to go with that. The project looks like this. We've got 5 different programs, and they span kind of the characterization, the ecological response, seasonal forecasts of temperature, identification of regions where we have thermal refugia, and also into then looking at what are the best ways to actually present or serve up this information so that different managers, agencies can actually use the products that are coming out of it. So today, as I said, I'm going to focus on the seasonal temperature forecasts and go into this in a little bit more detail because it is very topical at the moment. So when we go to the Australian Bureau of Meteorology webpage, we see predictions that are produced by their global coupled atmospheric ocean model that tell us what the forecast for ocean temperatures at the surface will look like in the coming months. And so this is showing you what's going to what is estimated to happen in the next over the next 4 months. But these are 1/4 degree resolution global ocean models that are run as ensembles. So we have some understanding of the statistics behind the predictions, but they're not really that useful for planning at the coastal scale, where a lot of important decisions need to be made, for example, about fisheries being closed. And so this project really has the idea to take the large-scale model forecast and use that to statistically downscale to a much finer resolution model. And the main reason, the main motivation for going down the statistical route is just to avoid the large computational cost of running a dynamically downscaled model. And so the approach has been to take this large-scale ocean model and a few different variables from that, as well as some of the atmospheric model variables, and use a regional model that was run over many years as training data to then generate a machine learning model to link the large-scale variables to the local variables. And so here's a little bit more detail in this approach. So the first step is to interpolate all of the variables that we're focused on down to the smaller scale. Then there is some effort made to make sure our data is all in very good shape before we do the training on 5 years of data. And this machine learning model has 2 parts to it, a convolution neural network as well as a residual corrective network. And that residual corrective network plays a role of pushing the data much closer to the prediction in the finer scales, but also allows it to look a little bit away from the conditions that it's seen before in the past. So we know that in a extreme model prediction, we need to account for the fact that those extremes might be increasing into the future. And so it needs to be able to predict in a condition that it's never seen before, which is not really what machine learning is designed to do, right? It's designed to make good models of things it's seen before. So these are all of the input variables. You see sea surface temperature, salinity, mixed layer depth, total depth, and then from the atmospheric, it's all of the heat fluxes. And we trained on just 5 years of a much longer regional ocean model data set. And here's just some of the results then that we took from our test period. So that 2011 marine heat wave that I told you about at the beginning, we didn't include that in our training so that we could then use it for testing. So you can see some snapshots of the difference, well, so the anomaly in the sea surface temperature at one point in time during that marine heat wave event. So all red, all much higher than the climatological normal. And you can see what this looks like in our global model and compare what it looks like in terms of the statistically downscaled model. So a lot more detailed features in there. We're able to reproduce some of quite a bit of detail within areas like the embayments, and you see these kind of extreme temperatures occurring in the coastal regions that are not so well identified in our large-scale model. And if we look at time series from a couple of different points that we've picked out here, so one on the open coast and one within this embayment, we can see if we compare the black line, which is our result of our regional ocean model simulation that, as a remind you, was not used in the training of this model, and the dark blue line is the machine learning model output. We can see that black and blue line are following each other nicely, and we can also compare it to what the global model is predicting at the nearest grid point, which is this red line. So the interpolation is not doing well enough, and there's actually quite a big difference between those two. So again, if we look in some more detail at the prediction of that 2011 marine heat wave, we can look spatially at the differences between the global and the regional, and then the machine learning in the regionals. And just note that we've got different colour scales here, so we're achieving much smaller variation between the regional model and the machine learning model. And so if we come back to the present, it's really been, after kind of a year of work, and I must say this is not my hands-on work. This is me supervising a talented postdoc who's a computer scientist. We have a situation where we have our fisheries agencies actually asking us for help in predicting what's happening with this marine heat wave that's unfolding now. And so we're able to run the machine learning model, taking the global model prediction, and give our fisheries people the downscaled model. And if we look in at a little region, for example, around Shark Bay, we can see some of the variability that's added in from our machine learning model. And we can see some regions on the coast here that are much cooler than offshore. So we can really move into a space where we're able to provide information quite different from the large scale forecast, although of course we can't be better than that large scale forecast because that's the thing that's actually dynamically produced. So we're kind of excited about where we're going with this, but we would like to be able to move these techniques to other regions around the world. And we're looking for opportunities to collaborate and hopefully see this used in areas of the world where, better decisions can be made as a result of its application. So just in closing, I'll leave my contact information here, and please reach out with any opportunities for sharing what we're doing.
I hope you hear. Yeah, there is a question from two questions. One is from opposite side of the world compared to Australia.
Okay. So, okay, Hazem Nagy, I'm from Marine Institute in Ireland. So I have one question because I saw at the first slide you were presenting two marine heat waves. One is ongoing for 5 months, the duration of it 5 months. So I think you used the HOP day terminology for defining the marine heat waves. So I think I don't know if what is climatology and threshold you have used. Did you include the cold years of last century in 1980s? So I think if you exclude these years, maybe the results will change. The other question is about the model you are using. Did you use any bias correction for this model? So to account on this model for predicting or to hindcast the marine heat waves? That's it. Thank you.
Okay, I mean, try to be brief, and Nicole, because we are a bit running out of time. And then
I guess in response to the first question, whatever your reference is, it's, I guess, undeniable the impact of the marine heat waves. So I guess my sense is that they are real if there's biological responses. But agreed, there's different ways of defining what your baseline, your climatology is. And yes, in answer to your second question about the bias, I'm not really sure what you're pointing to, so maybe we can follow up with this online.
okay, there is a short question from
Just quick one. Would your technique work with kind of very strong streams? We have the last 2 years in the intra-American seas in the Caribbean, Eastern Caribbean, we have had the hottest 2 years ever. So will your technique be able to do that if you don't have those in your training data?
So I think our current recommendation would be to take the technique and train on data that you have. So it would be good to have a few years of data in order to, so numerical model output in order to train well for a different region. The issue with translating the actual machine learning model to another region, I don't think it will work particularly well because the ocean, like, it's going to be picking up on things like, regions that are maybe more upwelling regions or regions where heat accumulates locally. So I think it probably won't do terribly well to translate the actual model to a different geographical region.
Okay, thank you so much, Nicole. It was a very interesting and fascinating talk. And now we move to Mitchell Harley, which...
Online question.
Oh, there isn't. No, but then now I cannot do that. I mean, Nicole, can you answer online to the question, because we start to be late, and we have another 3 questions in the chat. Yeah, I said. I mean, if you can answer online, there is a question for you in the chat. So now Mitchell will present CoastSnap. Please, Mitchell, floor.
Thanks, Giovanni. My name's Mitch Harley. I'm from the University of New South Wales in Sydney, Australia. So another Australian, so you'll have to put up with an Australian accent for a bit longer. So I'm going to present to you on my project called CoastSnap, which is a community-based project to detect changing coastlines. And I'm hoping that it will be recognised in the UN Ocean Decade very soon. So what is CoastSnap? It's CoastSnap's a very simple idea. It's basically a stainless steel cradle like you see here, where we install them overlooking coastal vantage points. And basically we put up a sign and invite the community to go and put their smartphone in, take a photo. And because it's always at the same position and viewing angle, over time those photos become a record of how the coastline is changing. But it's not just about the photos themselves. We actually, as I'll show you, have techniques involved where we can actually use these photos, this long record, to actually extract coastal data through techniques such as photogrammetry and now AI as well. This is our first station, which is installed in Manly Beach in Sydney, Australia in 2017. So it's been going for just over 7 years now. So why CoastSnap? Well, firstly, I think we all appreciate that it's the community directly participating in coastal science, which has been a huge theme of the workshop so far. It's extremely low cost. It's literally just a piece of stainless steel or even timber and a sign. It's very easy to roll out. One thing about this citizen science is that there's actually no training involved. Like anybody can simply place it, their phone in and take a photo, I think. So you can actually be contributing to data within 5 seconds as you're walking past a site. It creates these wonderful time-lapse movies that demonstrate the coastal change. I think it's fun and engaging. Can also be incorporated into education programs. We have some wonderful programs such as schools in Ghana using CoastSnap to monitor the local coastline, schools in Australia as well. But not just that, it's also, as I said, I'm a scientist. I'm interested in the data that's collected. So it does collect this quantitative data. It converts these photos into aerial photos, which is very similar to high-end satellite products with a resolution of about 1 meter. And the best thing about it is it's not affected by cloud coverage like satellites are. And then now we can leverage AI to track vast range of coastal data. So underpinning CoastSnap is basically this equation here. It's what is photogrammetry, basically converting the images that you see on the left, the oblique images, in what's called image coordinates with UNV. And basically rearranges all the pixels so that it looks like the photo is taken from space. And we do that from knowing some ground control points, so some fixed points in the image that we go and measure. And through that process, we can actually do this conversion to convert these photos, take it from the smartphone to miniature satellite images. Once we have it in that world view coordinates, we can then actually collect data. So we use shoreline detection techniques, recognizing the differences that using different color channels to identify the shoreline, the interface between the water and the sand. And then showing this red line here. And then, of course, we take into account things like the tide, waves, and things to know the exact level of that shoreline as well. And this is a technique. You're looking at the difference between the red and blue color channels to detect the shoreline. So we did some extensive validation of this technique. You can read about this in this paper in Coastal Engineering, but basically this image that you see on the left is a CoastSnap shoreline compared to us actually walking the shoreline. And what we find is the accuracy is about 2 to 4 meters, which when you consider coastlines that can vary up to 100 meters or so, we're more than happy to consider the low-cost approach. And this is an example. This is 1 year of changes taken at one of our sites. You can see all the dramatic changes and the time series of beach width taken from the photos. These are photos, we get approximately a photo every single day, so we can get incredibly high resolution data about how the coastline is changing. You can see this is a coastal lagoon and it's very dynamic as it closes and opens. On the left here, we have our signs. It's just a simple QR code which the community scan to upload their photos directly to the site. So, as I said, we started in 2017. We've since expanded significantly, such that we now have over 600 CoastSnap stations all around the world in 35 countries on 6 continents. I think Giovanni said CoastPredict is in every continent except Antarctica. CoastSnap is as well, although we're actually working on getting a station in Antarctica. And we also have collected over 150,000 photos to date. Here are an example of all the stations around the world, from Mozambique, Fiji, Netherlands, Colombia, and so forth. We do have a CoastSnap app, which really facilitates all the data being collected. It has a leaderboard so that communities can compete with each other. Currently, Spain is #1, and Australia coming second, unfortunately. But it has also, the data is a Creative Commons Zero license, so it's all getting access, and you can access all the data on coastnap.com. Now we're leveraging artificial intelligence to analyze the data. This is an example here of dune plant detection, and I can tell you, if you're a dune plant, you do not want to be too close to the shoreline, because you can see this growth of the dune plant, and in one wave event, it completely wipes out the entire population of dune plants. This is using meta segment anything 2 model. So we're starting to leverage more and more this artificial intelligence to track changes, not just to shorelines, but also to ecosystems. Finally, I'd just like to finish. We're also using CoastSnap as well for early warning systems. We have a coastal erosion early warning system in southern Australia on both the east and west coast. This is an example here where we actually have been using the CoastSnap data to actually record the impacts of over 250 storms, and using that data to actually then feed into an early warning system to create a data-driven forecast of coastal erosion. And what we're finding with this huge database of storm erosion, we can actually get much improved forecasts, twice as good as the forecast that you are getting from numerical models like XBeach. So this is a new application where we're starting to use as well with this data that's all collected from citizen science. And from that, I'd just like to leave it there. Thank you.
Thank you so much. I have many questions. One is, the last early warning system you presented, how long should be the training data set? Should be for that beach, or can you train the model on that beach and then apply to another beach?
That's something that we're working on now to transfer it into other locations. Generally, it's quite site-specific. But now that we have more and more stations and more years of data, we can actually use the same framework to actually build it at all the sites where we have CoastSnap stations.
One question, two questions, Maxi.
Yeah. So Mitchell, it's really nice to see you here. Welcome very much. We tried this connection long time, maybe 2021, right?
Yes.
So, and we are really happy that you finally can join. I don't know why the UN Decade is taking time, but we will check. Let us know. And so this is a system that has to be put in place through the Adaptation Fund proposals. We need to, this is really minimum, but maximum too. And, we really hope that we will be able to work together. One question I had is, so you're doing forecast for how many days in the future?
Up to 16 days. So
16, so it is the one. And so 16 days, and instead of competing with XBeach, do you think that a combination of XBeach and your data would increase the skill? You're already very low, 4 meters, right?
Yeah.
Is your skill.
That's something that we've worked on, doing these hybrid approaches. I think we actually have a lot of trouble with XBeach on our coastline. It doesn't work on these very high energy coastlines like we have in Australia. So it has poor skill, but I think in other areas you can look at seeing where XBeach works better, where these data-driven approaches work better, and so forth.
Thank you, Mitchell, again. Thank you. Now we move to next presentation, which is online, is Xavier from University of Calabar. Xavier, do you hear us?
Yes, I am.
Okay, thank you. The floor is yours. Try to be in the 10 minutes.
Okay,
10 minutes. Thank you.
you're welcome. Hello, please, my slide.
Not yet. Just a moment.
Okay.
Okay, just a moment, Savior. We were not ready.
Okay, no problem.
When you see on the screen, I guess you see the screen as well. Just a moment. Here we are. Please go ahead.
Okay. Thank you, everyone. I am Savior Odoakwaibi from the University of Calabar, presenting on environmental vulnerability mapping of West Africa. This presentation is going to take this shape. It's going to be very short and brief. There will be an introduction. After the introduction, I will give a brief analysis of the project objective and the project area, then activities and partner institutions, then I will conclude. Next slide. Environmental vulnerability mapping, West Africa, with abbreviation ENVIMAP, is a recently endorsed UN decade program project affiliated to CoastPredict program, with the focus to tackle the following decade challenges, but not limited to pollution, climate action, capacity development in West African coastal region. It is aimed at developing a pollution and climate change model for sustainable development of West African coastal zone, with initial attention to Nigeria. Next slide. Next slide. Because this project is designed to look into the issues of pollution and climate, the impact of climate change in the area, with the following objective: to predict. Nigeria in particular is an oil producing country, and we have a lot of oil activities there. So one of the objectives will be to predict marine oil spill pollution vulnerability, the plastic pollution associated with use of plastics in our country and their dissipation in the Nigerian coastal waters, and also to predict metal pollution. Nigeria is drained by two major rivers, River Niger and River Benue. It is not only oil pollution, we also have metal pollution from the north that also empties into the continental shelf. So one of the objectives will be to predict this metal pollution vulnerability in the coastal zone, and then the ability of most of the estuaries in Nigerian coastal zone to recover after this impact. And also the area, as according to the report by Ebetisu, and what we have studied to find out, the Gulf of Guinea, the coastline in the Gulf of Guinea is one of the fastest growing coastline, with the sediment transport rate of 1 million cubic meters per year. And with this, we have to also look into the coastal vulnerability of this area with respect to erosion. The first map there at the A is the Gulf of Guinea, with all the countries that make the area, with a particular focus to Nigeria, where we have River Niger and Benue that empties into the coastal zone of Nigeria, the Nigerian continental shelf. So the area marked by that rectangle is going to be the covering area, with Calabar, where University of Calabar is located, is at the eastern axis. So now going to diagram C, you have a network of estuaries that empties into the coastal zone of Nigeria, down with a particular focus to where we are working, the southeast coast of Nigeria, Ibono, in Akwa Ibom State. And this is the particular shoreline that we are working all the investigation from the Coastal Dynamics Department in the University of Calabar. This is our center of investigation. Next slide. Next slide, please. Hello. Next slide. I need the next slide. Okay, thank you very much. So this slide presents the coastal issues in the upstream of Paibo River estuary. And in 2012, 2011, there was a serious storm upsurge that made the updrift coastline adjoining Kwaibu River X-ray, as I shown in the previous slide. A segment of the updrift was submerged into coastal waters. As you can see, plate 1 there shows the attempt by the government to reclaim the land by bringing in companies to recover the sand that was transported into the sea back to the land. But you can see some pipelines there, and that is the graduated staff I used at that area during that time. But fortunately or unfortunately, the project was abandoned and the land was not reclaimed. So the people are still living in hinterland, living away from their own fishing settlement. So when I visited the place in 2024, that was last year, and I realized that there was no work done again. So, and one of the major issues that has to reflect climate change is the ecological succession of Nipa fructicans in the area that was initially covered by Rhizophora mangrove. So this is also an indication, although from the locals, there's information that the Rhizophora mangrove have been cut off for firewood and thereby making the ecosystem vulnerable to salinization of the coastal waters, making the area to be vulnerable to migrations of those indigenous species that used to have the Niger Delta coastal environment as the breeding and nursery ground for marine fisheries. Next slide. Next slide. Yes, in the downdrift segment of the beach adjoining Kwaibu River estuary, the impact of this increase in intensity of climate change leads to coastal erosion. As you can see, the area is highly developed, and we have a mobile oil facility behind the plate number 5, where we have beach tourism, but it is seriously affected now by marine and sea level rise. This area is affected by erosion, and sometimes, since there is no immediate facilities, the children use the beach for their recreation. So there is need for this project to look into the way in which the area can be protected from marine erosion. Next slide. Next slide. Next slide, please. Hello. Okay. So now in the West African coastal region, as I said, that we have been, according to the research by Betuso from Ghana, that our coastline, the Gulf of Guinea, is one of the fastest eroding coastlines in the world. So in Nigeria, in particular, as from number 1, the Victor there or plate number 1, we have the high level of impact of oil spills, gas flaring, and also coastal erosion. Then moving to number 2, Benin is erosion. Sierra Leone, there is serious impact of erosion. And in Togo, in fact, all the countries in the West African subsection are affected by coastal erosion. You can see from Togo, Ghana, and many others, Gambia, like in Guinea-Bissau, which is characterized by high level of tidal flood. It is getting down as a result of increase in sea level. Next slide. Okay, so this is a new project that is about to commence. These are the stages that we are going to pass through, the project management coordination, which we are going to design that will take care of this project, and then fundraising. We need funding from neighbors, from partners, from international agencies that will help us to operate this project effectively, and there will be engagement with end users. We have to consult and then invite all the end users, the government, the communities, the stakeholders in the marine sector in our coastal area, even in industries, on what they need also in this project. Then field sampling is going to be a coordinated sampling that has to do with advancing method in oceanography, not based on local technologies. So we solicit partnership and collaboration on integrated field sampling for this project. And we pray and wish that it has to be according to international acceptable standard and best practices. Then the data management is going to be made available to all the partners and also made available online after the collection of this data. There's a plan to have training workshop for capacity development for both students, staff, and early ocean professional. So this is the management framework of ENVIMAP, beginning with the UNESCO, the Ocean Decade team, down to the CoastPredict program, and then the University of Calabar, which is the lead institution, and other partner institutions. Next slide. So we have our focal point contact from the following partner universities, beginning with the University of Calabar, which is the host institution, Abubakar Tafawa Balewa University, Bauchi, CCMC Foundation, and Coastal Pollution Toolbox. We have Cultural Heritage Program, which is going to help in the integration of the cultural impact, the public health associated with the environmental pollution that has to do with the coastal zone. Nature Cares Research Center, University of Lagos, Lagos State Ministry of Environment and Water Resources, Supreme Program, NOAA, and Nigerian Institute for Oceanography and Marine Research, and Brandeisburg University of Technology. We request for more partners and collaborators in the areas of funding and donation of equipment that will help us carry out this project successfully. So in my conclusion, ENVIMAP is a multinational, multi-institutional, multi-science, disciplinary-based decade project, which is prepared and poised to develop knowledge that will be necessary to develop the coastal zone and also to catalyze the information needed for sustainable development of the area. Thank you very much.
So yeah,
Okay.
Thank you so much. It was a very nice presentation, and I guess you have a lot. We have a lot of challenges in the area to tackle, and I think we need to find, as you are pointing out, the funding to start this project, because you have everything clear in mind. So we will help you to, as much as possible, to find the funding and start the activities. Yeah.
Okay.
So any specific question? Otherwise, we move to the last presentation. But yeah, thank you so much for the moment being.
Okay.
So next and the final presentation of the morning is Alejandro Souza from Mexico, that will present the digital observing system of the Yucatan Peninsula.
Hello. This is sharing Nadia's dream. This is my little dream of DOSIS, which is the observing system in the Yucatan Peninsula. I've been there for 8 years, and when I arrived, I wanted to make this work because there wasn't very little done in shelf season in Mexico, and this very interesting area. This is the Yucatan shelf. The Yucatan shelf here, which is about 250 to 350 kilometers long by about 650 kilometers wide. So it's at least 70% the size of the North Sea, the entire North Sea. So it's quite a large sea. It's very shallow. The typical depth is 50 meters, which it's along here. No, it's over here. And it's lower than that everywhere. It's very flat. The slope is very flat, and it's microtidal. The other thing that we have is that, well, we'll see in a minute, but it's a western boundary current area, which is the important thing in it. But also, one of our problems is what were we interested in this area? Why people, not scientists, but other people interested, is one of the regions with which has plenty of tropical storms. This is the hurricane season in 2020. So we were all indoors thanks to the pandemic. And we were getting hit by 1, 2, 3, 4, 5, 4 tropical storms. So we are having in a single year, which is probably the worst that we had, not the worst hurricane, but the worst season amongst numbers of hurricanes. So it's a place that can have a lot of storm influence, and the problem we had here, it was more rain inundation more than coastal erosion, but we also had the coastal erosion problem. So it's one of the things we're interested. The other thing that we are interested is the harmful algal blooms. Yeah, this is they've been happening from 2001, 2003. 2008, 2011, and 2 years ago we had the last one, and they are quite bad because they can be quite long. I mean, this is and can have big effects. This 2003 one, it killed all the grass meadows. So when we're talking about this coastal green protection system that we have, if we start planting seagrasses and then get it destroyed by the harmful algal blooms, it could be hard. The other thing is this is the, and we'll see either tomorrow. Yeah, I think it's tomorrow. This is the third country in octopus fisheries. Yeah, and it has the most delicious, especially Europeans love it, octopus, which is the Mayan octopus. And you probably eat it and you don't know, you think it's Italian. But it is one of the most appreciated, and we have it here. And if you see here, during this, actually the bad one was 2010, it killed all the grasses, but it closed the fisheries and it closed everything in the sea for 150 days. So you can imagine the impact into the local community that's living off the sea, both from tourism and fisheries. Well, this is what I was telling you. We have the Yucatan current, which is before it becomes the Florida current and then the Gulf current. So it enters the Yucatan Strait. It has a typical value of about 1.2 to 1.5 meters per second, and it's pretty constant, at least in Nemo, in this area. It generates this little upwelling here, which brings cold, rich nutrients water into the shelf and makes grow things. It kind of gets two things. One is this fishery, which is quite important, but it's also a good attraction because in this area is where a big bank of whale sharks come and visit every year during the summer season, from May till September sort of thing. And it's a big tourist thing. And this is the same picture. This is temperature and it's chlorophyll. So you can see how the chlorophyll just comes there. And one of the things that you won't see on the surface is that sometimes the chlorophyll is underneath it's in the bottom layer. Yeah, although it's very shallow, it can be stratified. And we have things like, we have things as well that help us, not exactly where we are, but into the west and the Gulf of Mexico still. And we have the big oil company of Mexico. And at the north in the Gulf of America, we have the big American oil problem. So we can have any kind of problems. And what we want to do is we'll have these multiple stressors working onto us. And we have to look at how to have the toxicology, the marine pollution. We have a lot of biology and aquaculture and fisheries in there. So how does these things can interact and how we can do the monitoring and the predictions of how to do things. So the dream is our actual observatory, where we would like to have at least 3 real-time observation buoys sending us data from surface and bottom temperature, salinity, chlorophyll, and oxygen at least, and currents. And also kind of do at least a seasonal big cruise of the day of the area to see how it's behaving. What we want to do as well is we have the satellite images that we are using at the moment, but we also have like transport models in here, is Lagrangian models that have become very fashionable to do either the transport of larvae or algae or pollutants or whatever. Satellite images also showing here. This is not a biggish problem in our area. It's further west and south where the sargassum, this is images showing sargassum coming. This is one of the rare times that has got into the northern Yucatan. Normally it's in here. And this is a 200-meter contour currents of Nemo Orca NEMO actually, not the Copernicus one, but showing the current and the temperature, kind of how it brings cold water. Cold water is 25 degrees, 22 degrees in our area. Yeah, so those is the first step into getting to this, and is getting all the near real time data that we have available. So we are trolling things like the University of Southern Florida, the Copernicus, and get the satellite images and the models and work into it. Step 2 is get our downscaling models, which we are working in collaboration with UCLA, with ROMS, and with CMCC here in Global CoastPredict, trying to get SCHIFM working. I've heard yesterday that NOC has a model that it's been stopped, but it's there for a 1 kilometer NEMO working in the area. So that might be interesting to use, and probably in the IOC Caribbean project if it comes. And we want to get like new observations, trying to get funding. I've been trying to get funding from the Mexican government, which, since we have our new left-wing government, it has changed a lot with science, and we don't fund much. So it didn't get success with Schmidt Institute, but we're trying now with IOC Caribbean and see if we can get the observations funded. So I think, there's a little bit more about the hormonal algal blooms. We have, what are we doing? What are we doing in data at the moment? We have monthly the stations really in the coast where we are looking at it, and we have a fast response observations done by the primary productivity lab in there, and in here we're looking at where we have high concentrations of the algae causing the bloom, and how it advances during that year. And at that time, we have the full coast full of it, except kind of the middle. For some reason, it was very patchy. We are making measurements in our small boats at the moment, up to the 20-meter isopath. And we're making CTDs every 3 months, every 3 months. And also we have a transect that we're doing every 15 days. And in those stars that you saw, we have 3 ADCPs that are mounted, although they are not real time, but we are collecting that data. Our dream is that everything would be real time. This is the 3 sections going from the east to the west. This is the complete west. This is towards the west, and this is the east part. We have another one now done in the middle, which it's a very interesting part that we start. And this is one of them, which we're doing 15 days, and is how just rushing through time when we're getting the CTD data. So we're working very hard there. This is satellite images that we're getting, chlorophyll at 300 meters, get from Copernicus data, and their components in the small different sizes. But also we have things like the forecast that we can get from Copernicus at the moment, and it was for the 31st of January because I had to do different things. And we can see in the temperature, in the salinity, and certainly current, how the Yucatan current is very well represented all the time. And as I say, it's very, very constant, at least in the model. And we have information like wave information, where we have high waves, again, within the Yucatan current, very small waves in the Yucatan shelf, and they are coming at this moment, they are coming from the northeast. Right. So we're doing, as I say, we're trying to get SCHIFM. This is the grid that they are working at the moment. And we're working with ROMS with a 1 kilometer model and looking at that. They told me to make comparisons. Well, with America, we have the Gulf Stream in here, and it has similar upwelling processes happening at least in the South Atlantic bight. Certainly in the Kuroshio region area, and happening in the East Australian current, in the Brazil current. And the Gullas current didn't happen, but you have a lot of things happening there that can be masked, but this kind of upwelling. And the other thing is, I didn't mention now, but this is a karstic area, and all our fresh water sources are from underground. And you'll see tomorrow they are fairly polluted. But that's one of the things. Another thing that we have in common with you in Italy, in here, this area, you have all that, and that's what my question yesterday is like. Right. So how we deal with this in our models, and in our particular case, we have a lot of problem with we will have a lot of problem with the biological model.
Thank you, Alejandro. It was a fantastic talk. Congratulations. Yeah. So, as Alejandro was saying, we have Gabriel now visiting CMCC. So that's also another way of collaborating within Global Coast and CoastPredict. Any question? Yeah, Nadia.
Fantastic, as usual, Alessandro. So I detected some problem in getting the CMEMS real-time data because you were using Orca.
No, the original study that I went to do
So you
Yucatan,
use.
when I went to Yucatan, when I moved there, I took the Orca data that NUC had produced and I did an old analysis of that. But now we are working with for the forecast. We're working with Copernicus data, and we don't have any problem.
Is there no problem?
We have
right?
no problem.
Okay, just for us to know, because for the cloud and everything, we should find also a way to be easier. What is the major problem for you to access the Copernicus data?
I mean, probably the biggest problem is the bandwidth in my institute, but I haven't got any problem.
That's good.
They are very helpful. We had problem a year ago, and they gave us ways to bypass it and everything, so it's no problem.
Oh, but the bandwidth is interesting because I mean, if we move to the cloud, we will not move the data in the institute. So I guess we'll help. So thank you again. And just to mention that this session has been dedicated to projects that are a different level of development, fully funded or project ideas, and but well structured. And these are endorsed by the UN Decade. And yesterday we mentioned, was it yesterday? I guess, yeah. We mentioned that DCCCR, the center that Nadia is leading, can help any project to be endorsed. So in the endorsement process, you can count on us. And then you become more visible and hopefully associated to CoastPredict. So that was the aim of the session. Then we conclude, and I think we have discussed along the presentation. I thought it was more useful. And we are almost on time, a bit delay, and we can go to lunch. Thank you, everybody.